Hello, a follower sent us this problem. He was asking for our help to get the derivative of this function. We have here the f of x is equal to the root of x plus x all over the root of x cubed. Now, to approach this problem, what I'm going to do is convert everything into exponents so that again, because I am more familiar with exponents, so I will have square root of x is just x raised to 1/2. Then I have here plus x all over x. I will have 3/2. Alright, so after this one, I'm going to make use of the quotient rule. So again, I'm going to set this one as my u, and this will be my v. So again, according to the quotient rule, this is just equal to the derivative of u times v minus the derivative of v times u all over v squared. Alright, so let's do that. What is the derivative of our u, or our first function? That is just equal to what? Let me just use. Right. So what is the derivative of this one? That is just 1/2, and then x. We have 1/2 minus 1. That's negative 1/2. So we have negative 1/2, and then we have derivative of x, that is just plus 1. Alright, and then multiply it by our let me just have multiply it by x 3/2. Alright, and then minus the derivative of this one, that is just let's say x, let's say 3/2. Then we have x. What is 3/2 minus 1? That is just 1/2, right? This is 1/2. And again, multiply this by our first, our u, which is 1/2 plus x. And then again, we have x 3/2, we have squared. So we are going to simplify this one. So simplify everything. This will give us what? What is this times that? That is just copy the 1/2, and then same variable, this one and this one. And then when we multiply exponents, we just add, right? So we have negative 1/2 plus 3/2. This is just what? This is just 1. So meaning to say, this and that is just 12 x. Alright, next, what is that and that? That is just plus x 3/2, and then minus we are going to get the product of this, that, and that one. So again, minus we have 3/2 x times x raised to 1/2 times x raised to 1/2 is just x, and then plus we have 3/2. What is 1/2 plus 1? That is just 3/2. So we will have x 3/2. Right? And then at the bottom, we will have what? This and that is cancelled. We will get x cubed. Alright, so again, we will get x cubed. Now, what do we do next? We will now combine like terms. So as you can see here, this one and this one are like terms. So we can actually combine them. That will give us what? That will give us 1/2 minus 3 over 2. That's just negative 1. So we have negative 1 or negative x. Alright, that's negative x. And then next we have this one and this one. So again, be careful of the sign. That's minus, right? That is minus. So what is 1 minus 3 over 2? That is just negative 1/2. So we will have now minus 1 over 2, and then just copy x 3 over 2, and everything is all over x cube. Alright, now we are going to simplify further. This one, that is just equal to 2, and then to make them the same or like term, so you have 2, so this will become negative 2x. Alright, and then minus x 3 over 2. And then we proceed to what? We actually proceed to multiplication, reciprocal of that one, that is just 1 over x cubed. So multiply by 1 over x cubed. We will now have negative 2x minus x 3 over 2 all over 2x cubed. Alright, and then one more thing, we have here a common factor, so we are going to take out negative x. Alright, so take out negative x. What will remain is what? We have 2 plus what is 3 minus 1? That is just 1/2, right? So that is just plus x 1/2, and then again all over 2x cubed. So notice here that this can be written as x times 2x squared, right? So meaning to say, we can actually cancel that one out. Cancel. We were left with negative 2 plus x 1/2 all over 2x squared. Alright, or to simplify further, this is just what? This is just what is x exponent 1/2? That is just square root of x, right? So we will now have a negative 2 plus square root of x all over 2x squared. So this will be our answer for this exercise, or if you want, you can actually rewrite this one as, again, they are equal. We have negative x plus 2 all over 2x squared. So again, this will be our answer for this exercise. I hope that makes sense. So again, I hope that makes sense.